Hi, my name is Zana Zana Abidin. I'm going to present about psychometric chart. So, psychometric chart is graphical representation of the physical and thermodynamic properties of air. So, four parts of psychometric charts. First, wet bulb temperature, dry bulb temperature, dew point temperature, and humidity ratio. How to read humidity chart? First, we must find humidity ratio. Locate the humidity ratio, sometimes labeled as a mixing ratio. This will be along the right vertical axis, which is x-axis. Humidity ratio units are grains of moisture per pound of dry air or grams of moisture per kilogram of dry air. Next, dry bulb temperature. Dry bulb temperature is located on the horizontal or x-axis of the psychometric chart, and lines of constant temperature are represented by vertical chart lines. Low temperature that range from negative 20 degrees FTB to 50 degrees FTB, while normal temperature that range from 20 degrees FTB to 100 degrees FTB, and high temperature that range from 60 degrees FTB to 250 degrees FTB. Next, how to find dew point temperature. First, locate the dry bulb temperature and humidity ratio to get dew point temperature. Draw a horizontal line from the point of intersection towards the wet bulb temperature. At this temperature, moisture starts condensing from the air. Lastly, wet bulb temperature. This is a typical temperature standard reading if the sensing bulb is covered with a wig or socks and exposed to airflow. Wet bulb temperature is located along diagonal dotted lines leading to scale reading at the upper curved boundary mark saturation temperature.
Hi, my name is Rafi Abidin Roslan and I'm going to continue part 2. Example number 1. Moist air saturated at 2 degrees Celsius enter a heating coil at rate of 10 meter cube per second. Air leave the coil at 40 degrees Celsius. Find the required rate of heat addition. Heating coil. It's a sensible heating where delta HR, which is humidity ratio, is equal to 0, which means humidity ratio 1 is equal to humidity ratio 2. Rate of heat addition is Q is equal to mass flow rate times delta H. Well, how can we find mass flow rate of dry air is by dividing heating coil rate with specific volume. We can find delta H, change of enthalpy, and specific volume in graph. Okay, right here. As given information from the question above, we can create a line. Of temperature of dry bulb for 2 degrees Celsius and 40 degrees Celsius. Okay, as stated in the question, the saturated air. So we can proceed the line to the saturated line here, and we can find its humidity ratio, and the humidity ratio with the 40 degrees is same since it was heating coil or sensible heating. So we can find another information that we needed for this question. We need enthalpy. So we can make a line that parallel to the enthalpy line, and we get at this line. See, for 2 degrees Celsius is 13, while for enthalpy for 40 degrees Celsius is 51.5. After we get all the information that we needed, we can calculate mass flow rate. Here by using the equation that I said before, which is 10 divided by 0.784, which is it was a specific volume from the dry air. We can find the specific volume of dry air. Here, the blue line, we make the line parallel with the specific volume line, and then we will get 12.755 kg per second. Okay, and then we can calculate the rate of addition. Okay, and we will get 451.07 kilowatt. Example number 2. Okay, as we can see, the question, moist air at 30 degrees Celsius dry bulb temperature and 50% RH, RH is relative humidity, enter a cooling coil at 5 meter cube per second and it processed to a final saturation condition at 10 degrees Celsius. Find the kilowatt of refrigerant. Find the kilowatt of refrigeration required. Okay, the formula that we need is for the power of refrigerant is equal to mass flow rate times delta H minus delta HR. For mass flow rate of dry air is equal to cooling rate divided by specific volume. We can find it in table or graph. Okay, we can plot all the data that we have, okay, such as the temperature of dry bulb. We can plot it and make a straight line to 10 degrees Celsius and 30 degrees Celsius. And then as stated at the question, for 10 degrees Celsius, it was a final saturation condition, which means that the line should have passed the saturated line, and we will get the horizontal line, which is its HR, humidity ratio, and as stated in the question, we get 50% of relative humidity. So we use that and make a line. This yellow line was humidity for 50%, and we will get the intersection between the straight line with the yellow line, and the intersection we can find humidity ratio, which is 13.5, and we can get its enthalpy, which is 64, and the enthalpy for 10 degrees Celsius is 29. After we get all this data, we can calculate what they want. First, we can calculate the mass flow rate of dry air, which is 5 divided by 0.878 equal to 9.6 equal to 5.96 kilogram per second. Kilowatt of refrigeration is equal to 199 kilowatt by using the equation. Okay, for last question, example 3, 2.5 cubic meter of lumber is being dried at 55 degrees Celsius dry bulb temperature and 31 degrees Celsius wet bulb temperature. The drying rate of the lumber is 9.5 kilogram of water per hour. If outside air is at 26 degrees Celsius dry bulb temperature and 70% relative humidity, how much outside air is needed per minute to carry away the evaporated moisture? Okay, we can use all this data and transfer it into the graph, and we will get another information. Okay, the information that we need is in this question is specific volume and humidity ratio. Okay, as a given in the question, we can plot the dry bulb temperature for 55 degrees Celsius and for 26 degrees Celsius, and we will get another information such as the information for 55 degrees Celsius dry bulb temperature is 31 degrees Celsius wet bulb, and for the 26 degrees Celsius we have the relative humidity. Here the blue line was 70%, And when from the intersection, we can get the specific volume, which is 0.868, and the relative humidity is 15, and another one relative humidity is 18.8. We can solve the problem by using this equation delta HR, and we will get the value is 0.00338, and the mass flow rate is 2500 kg per hour. And we can calculate the volume flow rate, which is the final answer is 36.17 meter cube per minute.
That's all for me. Thank you.